So in this video, we're going to explain what a limit is. And we're not going to look at any textbook problems or use any mathematical symbols. I'm just going to try to give you a common sense explanation that gives you the real feel of what a limit is, and more importantly, like, why do we use it in engineering? So let's start with this. We can't divide by zero. For some reason, we've just been told that for years. Why? Well, I don't know. It results in undefined or does not exist or something like that. Let's go back in time. Mathematicians were really wondering what does happen when you divide by zero. And the way they went about trying to answer this question is they started by putting in a number that was close to zero, like 0.1. We'll just make an XY table here. If I put in 0.1 into this equation here, I get 10. Okay, let's try putting in 0.01. We're getting closer to 0, and that results in 100. And then we put in 0.001. We're getting even closer. 1 divided by 0.001 is 1,000. So we start seeing a pattern here. As we get closer and closer to this number being 0 exactly, the y, that is the output of this mathematical unit, is going to get bigger and bigger and bigger. So at some point, people kept doing this. They kept shooting in numbers in here, getting closer and closer to 0. So after a while, people said, all right, that's it. Let's just call it a day and say that this thing will basically become infinity. And infinity is not a number. It is not defined. Defined means we're saying that something is something. We're labeling a concept and we're saying it is that and always that. But in this case, this y, it keeps shooting, and it keeps even going. We can't capture it. We cannot define it. That's why people say that when we try plugging in 0 in here exactly, that results in undefined. But I always like thinking that it means, basically the idea of infinity. So actually, we just took a limit there. A limit is the idea in engineering that we don't try to answer our question by going right for it, by plugging in 0 right in there directly. We try to answer our question by getting closer and closer to the thing we're trying to test. And we try to inch closer and closer and see how our system behaves and responds. And engineers do this in experiments all the time. The limit is so much more than just a math thing. It's really a way of testing and experimenting with things. But in our conversation about calculus, we did take a limit. We just let x approach 0 from the right. If you think of a number line and here's 0, we were plugging in 0.1 and then 0.01 and then 0.001. So we were plugging in x's that were getting closer and closer from the right-hand side of the 0. That's what, whenever you see a sign that's to the right of a number, that's what that means. It means where you're approaching from. Usually the sign's on the left. But in this case, for the purposes of limits and stuff, the sign on the right means where we are approaching from. And we can approach from the left as well. How about let's do that? I'll plug in a negative 0.1 I'll get a negative 10. I'll plug in a negative 0.01. I'll get a negative 100. And you can already see the end of this story. The end of the story is that it doesn't end. As we keep making that x get closer and closer to 0, but from the left-hand side, the y, the output of this equation, will approach negative infinity. It'll be a negative 1,000 and negative 100,000 and on and on and on, negative infinity. So, negative infinity. We approach this thing, we approach 0 from the left, we get negative infinity. We approach 0 from the right, we get something different, we get positive infinity. So we're getting two answers, two behaviors from this thing based on different ways of approaching the same question, which is really wacky. So wacky that we just call this thing does not exist. And that's another term you may hear when people say what happens when you try to divide by 0. It does not exist. So, for this equation, we tried making x get closer and closer from the right-hand side. In other words, we just took the limit. And we got positive infinity. And then, for our same question, we tried making x get closer and closer to 0 from the left-hand side. In other words, we took the limit. And we got that this whole thing was approaching negative infinity. So, if we try to approach 0 from both sides, that's what this means. Notice that there's no sign here. When there's no sign here, that means both sides. When we try to approach from both sides, and we try to see if our two left-right experiments agree with each other, and they don't, that means that this limit does not exist. There is really no solid answer. So we have some notation here. Just remember, we got the approach from the right, approach from the left, and when there's no sign here, that means we're approaching from both sides. We look at the right experiment, the left experiment, and we see if they agree. And in this case, they did not agree. So the limit approaching from both sides does not exist. So I hope this was a conversation that really helped you to get more of a common sense grip on what a limit is and why we even use it in engineering. You'll see the idea, the thought process of a limit in many other engineering concepts. So I hope this was able to give you a solid grasp conceptually the background of what the limit thought process is.